pretty much a lot of these sections roll into each other. And all section 4 really was about is what functions are and how to recognize them, how to graph them, and how to determine whether between linear or parallel and perpendicular lines. What are parallel lines? Okay. And then perpendicular? Okay, so that very good. So you guys are ahead of the game. So there are 4 possibilities here if you have 2 lines. These are the 4 possibilities. This is line 1. This is line 2. Line 1, line 2. Line 1, line 2. Line 1, line 2. And we always refer to the slope intercept formula when we deal with lines. So to compare 2 lines, they both have to be in this form. So what are these called? And we abbreviate. So what are the conditions for parallel lines? They have lines never touch. Okay, true. But why don't they touch? Right, because they have to have the same slope and their y-intercepts must be different. Because if their slopes are the same and their y-intercepts are the same, then what are they? They're the same line. So this left side, the first thing you do when you have 2 equations, first off, you have to put them in slope-intercept form, then compare the slopes. If the slopes are equal, they're either going to be parallel or the same line, depending on their y-intercepts. What's this called if it has a 90-degree angle? And then that abbreviation is upside down T. And this last one is any other pair of lines. On the left side, we compare them with their slopes being equal. On the right side, their slopes have to be different. Now, if their slopes are different, does the y-intercept play any part in the next part? Why? But what if the y-intercept is right there? It's not, they will reach the same point. But if the slopes are different, they have to intersect at some space and time. If the slopes are different, you're guaranteed one solution. And solutions are where they intersect. We don't worry on this other side. If the slopes are different, we don't worry about the y-intercept because the y-intercept can happen where they intersect. So they could be the same, they could be different. So that's not even a contention anymore. Only if the slopes are equal. So the distinguishing factor between perpendicular lines and anything else is the slopes of perpendicular lines have to be negative reciprocals of each other. They have to be negative reciprocals of each other. What does that mean? The signs have to be different. And two, they have to be flips of each other. Or we matter reciprocals of each other. And any other, as that's if they have different slopes that don't match these other conditions, then they're just going to intersect somewhere. And then what do you need to find an equation of a line? The y-intercept and 2 points? That would work, that would help. But what you really need, minimum, are 2 points. Or you can say, instead of 2 points, if you have 1 point and the slope between the points. The y-intercept, yeah, that is a point that you could be given the y-intercept, but it's just any general point. So how are these two the same? No, how is when finding equations of lines, which I'm going to call EOL from now, having 2 points or 1 point in a slope, why are they the same conditions? Very good. That's it. Because you can find the slope from the 2 points. But in bottom line, you really need to have a point and a slope to go in there from there. Find the equation of the line going through the point 5, 5 with slope 3. And then so find the EOL for both of these. Oh yeah, yes, I see what you're saying now. Yes, to find the actual equation, you need to have the slope and the y-intercept. Yes, I see where you're getting from. Why did he say that? Because when I say equation of line, what form is that? Y equals mx plus b. The y and the x have to remain in the equation. The only variables that change are the slope and the y-intercept. So that's what, yeah. Now I see what you're saying. Yes. And we'll use this to find our equation of line. Since we have our slope, we have a point. Plug them in. What's the only thing we're missing in this first one? We're missing the b. So if we plug in our slope, our x, and our y, we can solve for b. Times 5 is 15. Subtract 15. Since 15 is bigger, it's negative. 15 minus 5 is 10. So the y-intercept is at the y equals negative 10. Since we have this, and we have our slope, just plug them in there. And there's your equation of the line. As you said, if we have 2 points, our first step there is find the slope. y2 minus y1, x2 minus x1. So we label my points x1, y1, x2, y2. y2 is negative 9 minus 1, 7 minus 2, which is negative 10 over 5. So my slope is negative 2. Now we have our slope. We have 2 points. So here, just choose either point. And this is really one of the only times you have the free choice to make whatever choice decision you want. So we make it logically. Which point would you use? 2, 1. Keep away from negatives. And if it has 0, keep away with negatives and fractions. If they have a 0, use that. And if they have just regular numbers, so they're all doable. It's just that some of them have less chance of mistakes. So I'm using 2, 1. So I have the point 2, 1, and I have the slope negative 2. So now that puts us back in this condition. This is my y, this is my x, and this is my m. So I have 1 equals negative 2 times 2 plus b. Add 4. So b is equal to 5. M is negative 2. B is 5. Plug those back in the equation. Y equals negative 2x and a positive 5. And there's your equation of a line that connects those 2 dots. Pretty straightforward. Finished. Real quick, let's look at. This is the slope that's given. The parallel slope and the perpendicular slope. So I'm going to give you the slope. You tell me the slope that's parallel to it and the perpendicular slope. Don't yell it out just yet. We're going to do all four of them first, and then we'll go through them. Next one. Next one. And the last one. Undefined. All right, so let's look at the first column, the parallel. What's the first one? Second. Right, because parallel has the same slope. How about perpendicular? Wisdom. Good. And the last one? Right. Let's see why this is. Yeah, the parallel ones are easy. It's the same, whatever the slope is. Every number is a rational number. It's a fraction. Perpendicular is I have to change the sign. That's negative. This one has to be positive. And I have to flip the numbers. This one's positive, so this one has to be negative. Flip the numbers. So those are pretty easy. 0 is 0 over 1. 0 doesn't have a sign, so there's no sign change. If I flip it, I get 1 over 0, which is undefined. If I start off with something that's undefined, then I automatically have 1 over 0. When I flip it, I get 0 over 1, which is 0. So when you get to questions that ask for find the equation of the line parallel or perpendicular, set it in the slope-intercept form, find the slope, and then find the slope parallel or perpendicular from there, and use the equation from that. All right, so that was pretty much 4. And it's super easy. Let's do 5. Linear equations. We've learned how to create them, how to graph them, how to manipulate them. We learned what they were and how to notice them, identify them from a bunch of equations. Now we're going to talk about solving linear equations. When you solve something, well, first off, when you said solving, it has to be an equation, which means what? It has to have an equal sign. When you solve for something, you come up with what's called a solution, but it has other names. What other names could solution mean? The sum? No. I mean, I'm talking with when we deal with lines. We look at the x-intercept if it's only one line, or the point of intersection if you deal with two lines. Very good. Another name is the root of an equation. And there's one more. Sip on it now. It's the root of an equation, the factors. So whenever you're asked to solve something, there's other ways they can say it. To find, it's a process of opposites. Well, the order of operations goes from special operations to multiplication, division, to addition, subtraction. It goes top down. Yeah, special operations always has to get done first because that separates the numbers. When you solve them, you get rid of the plus and minuses first. Then you get rid of anything that's multiplied, divided. And then you solve. Solve for y. So what's the first thing? Yeah, we have to get rid of anything that's added or subtracted to the variable in question. 4x is added to it. So what's the opposite of 4x? Negative 4x. Why do we do it to both sides? Right, because the equal sign is actually a balance beam. It's a focus. The golden rule. Whatever you do to one side, do to the other side. So we end up with 2y equals negative 4x plus 6. And then, since there aren't any more addition subtractions, we get rid of any multiplication divisions. This is 2 times y, it's multiplication there. So the opposite of multiplication is division. And typically, people write it this way, which is not bad. But what it really means is this. When we deal with equations and graphing and solutions, we want to know each particular term separately. So whenever you divide by a coefficient, divide it in each term separately. The answer is going to be negative. 4 divided by 2 is 2. 6 divided by 3, or 6 divided by 2 is 3. That's easy. Example 1. as a general rule, whenever you have fractions and equal signs, get rid of the fractions. You have fractions and equal sign. Get rid of the fractions. And it's always going to involve 5 steps. Step 1. Find the least common denominator. The least common denominator is the smallest number that all the bottom numbers fit into. In this case, it's what? Why is it 20? Yeah, if instead of trying to figure it out, just multiply 4 times 5. Yeah, it's the easiest way because you may have 4 or 5 different denominators. Just multiply them together. Eventually, it'll wash out at the end anyway. Okay, before going any further, how many terms do we have? We have how many? 3. A term is anything separated by a plus, minus, or equals. There's 1 term, 2 term, 3 terms. Because what you do there is now you multiply the LCD to each term. So just put a parenthesis around each of the terms separately. And multiply each one of those parentheses by the LCD. The convention of multiplying fractions is before you do anything, before you multiply fractions, reduce them first. Never just multiply straight across top by top, bottom by bottom. Always reduce first to see if anything's going to be simpler. Because if you just multiply straight across, then you have bigger numbers to try to see what they have in common. This way, if they're smaller, it's much easier. So, and we know that each of the denominators have to cancel. Why? Because the LCD has those in there. 4 goes into 20 5 times. 5 goes into 20 4 times. These 2 equations are identical. Which one looks easier to solve? The bottom one. It's just if you get rid of the fractions, even though fractions aren't really much more difficult, it's just we've had bad experiences growing up with fractions. Step 4 is multiply to remove the parentheses. 5 times 3 is 15. Minus 20 times 1, 4 times 7. And then solve for the variable. And it's always going to be those 5 steps. Since we're solving for the only variable there is the x, we get rid of the 21st. $15. Do they have anything in common? 15 is made up of 5 times 3. Does 3 go into 48? 3 goes into 4 once with 1 left over. 3 goes into 18 6 times. So we have 16 over 5. The computer will take that, even though in mathematical world, it's not an accepted format. Why not? It's an improper fraction. Yes, the top one's bigger than the bottom. It's an improper fraction. So how many times does 5 go into 16? With how many left over? And that's called a mixed number. Example 2. Are there any fractions? No, so we're good there. Can we do anything inside the parentheses? Order operation still applies, so we have to do the special ops. Nothing, so we get rid of them. We multiply. 2 times 5 is 10. Positive times negative is negative. 2 times 3 is 6. Bless you. Then we have negative times positive is negative. 3 times x, 3x. Negative times positive is negative. 3 times 2 is 6. Whenever you get rid of parentheses, first thing you should always do is combine like terms. There's nothing to do on the left side, but on the right side, we have 8 minus 6. 8 minus 6 is 2 minus 3x. Now we have a decision, another decision to make. We have x's on both sides. Which one do you move to the other side? Which is -6 is smaller than -3. It's further to the left on the number line. Why do we move the -6 over instead of the 3? To turn it into a positive. Yeah, because since they both have negatives in front of them, if we move the smaller one, we have to add 6 to both sides. We're not going to have any more negative signs in front of the x's. So it's 6 minus 3, that's positive 3x. And then solve for x, since now we only have one x in there. Subtract 2. 8 equals 3x and divide by 3. So x is equal to 8/3. Improper fraction. So this is how it works for those of you who aren't refreshed with that. 3 goes into 8 twice. 2 times 3 is 6. This is your remainder. So it goes in there twice. 2/3. And this number here goes in front. So that's our solution. Get used to checking your answers. Because this is one of the only classes where you should know your grade ever before you ever turn in a test or a homework. Plug it in there, 8/3. If it works, great. If it doesn't, then you did something wrong. Try it again. Example 4. Will you always get answers? No. Well, yes. I mean, yeah, this is pretty straightforward. You can see that the same coefficients. But again, just practice your process because it's not always going to be this simple. So we have fractions and an equal sign. Step 1, what's my LCD? Yeah, it's the only denominator, only bottom number. So the next step is multiply the LCD to each term. There's 1 term, 2 terms, 3 terms, 4 terms. So 3 times 3. Reduce. So 3's there's cancel. So multiply, then solve. 3 times 3 is 9, minus 1 times 1 is 1, x. Positive times negative is negative, 1 times 1 is 1, x plus 9. We add x to both sides. So what does that tell us? Yeah, so any x you put in there, any value x, it'll equal the same. Because 9 always equals 9. if you end up where the x's cancel, but it equals, if your final solution looks like that, then there are no solutions possible. So if the x's disappear, if the variables disappear and what you have left are equal, then you have infinite solutions. If they cancel and you have something that's not equal, then you have no possible solutions. Anything else will have an x in there and you'll have an answer. Any questions so far? Now let's look at word problems. Oral languages. There are about 232,000 words in the Japanese language. That is 19% more than the number of words in the Russian language. How many words are in the Russian language? Let's see. We know there are Japanese have 232,000 words. This is 19% more than Russian language. So what is the relationship between the Russian and Japanese languages in this, with this statement? We're looking for the, how many words are there in the Russian language? And so the Japanese language minus 19% of the Japanese language equals the Russian language. Because what the statement originally says is the Japanese language has 19% more words than the Russian. So 19% of the Japanese language plus the Russian language equals Japanese. Move that over, and we have this. We have to convert percent. Percent means 1/100. Per 100. Cent is centi. What that means is move the decimal place to the left, because you're dividing by 100. Each space, so you have 19 divided by 100. Each zero you're dividing by is one more step to the left. So it's 0.19J equals R. So we have 1 minus 0.19 is 0.81. So the number of words in the Jap, 2000. this equation, since we have two zeros, we can say 81 because we move the decimal point to the right by getting rid of two of those zeros, and we do simple multiplication. Zero, two, 2, 0, 16, 25, 18. So the Russian language has 187,920 words. All right, let's look at the next example. Example 5. Convenience stores. In 2014, there were 151,282 convenience stores in the US. The total number of convenience stores in Texas and in California was 26,379. There were 4,003 more convenience stores in Texas than in California. Find the number of stores in both of those states. So let's convert that into math statements. This is example 6. So what do we know? What does the first sentence tell us? The second statement, the total number of stores in Texas and California is 26,379. So how do we put that in math? Equals 26,379. The third statement says there were 4,003 more stores in Texas than in California. So if they were equal, we'd put that. But if there are 4,003 more stores in Texas than in California, how do we make them equal? We have to add 4,003 here. So now we got to find the number of stores in Texas and California. You had a question?
Oh, I was
What part?
you said we have to add the 4,000.
3, because yeah, Texas has 4,000 more than California. To California. Because to make them equal, so let's say Texas had 3, together they had 10 or whatever. So if Texas was 3 or it was 10 and California was 2, how many more do we have to add to California to make them equal? So since California is lower than Texas, we have to add the extras there. So now what do? We have two equations and we have two variables. And so we know what t equals. Anywhere we see a t, we have to combine both of those equations. So Texas is California plus 4,003. That's this T. Plus C equals 26,379. Combine like terms. C plus C is 2C. Get rid of pluses and minuses first. So subtract 4,003 from both sides. Nine minus 3 is 6. 7 minus 0 is 7. 3, 6, 2. And divide by 2. Two goes into 2 once. 2 goes into 2 once. 2 goes into 3 once with 1 left over. 2 goes into 17 8 times with 1 left over. 2 goes into 16 8 times. So California has 11,118. 188. 11,188. And then now with this one, since we know what C is, we go back to the where we have Texas defined. Texas, the number of Texas is C plus 403, 403. So 11188 plus 4003. 9 1. So Texas has 15,181. To check, we have to make sure that T plus C equals 26,379. $15,191 plus 11,188. And they're equal. So all right, let's look at another word problem. Now, whenever you deal with things that move, we use the distance formula. Now, this is not the same as the Pythagorean theorem we had earlier because this is a motion problem. So now, when things move, you will always have to have a time variable in there. So distance equals the rate, the speed of the object times the time it moves. So D equals RT. Because from this equation, you can find other variables. So what's the rate? How fast is something moving? Well, to get the R by itself, what do? Divide by T. If you think about it, the speed that you drive is miles per hour, distance over time. Or the time you travel. To solve for T, we have to divide both sides by R. So the distance divided by the rate. So they all come from the same equation. Example 7. Airspeed. Delta's airline fleet includes 737-800s, each with a cruising speed of 517 miles per hour, and the Saab 340s with a cruising speed of 290. Suppose that a Saab 340 takes off and travels at its cruising speed. 1 hour later, the 737 takes off, following the same route, traveling at its cruising speed. How long will it take the 737 to overtake the Saab? So as we see from pictures, is the Saab took off first and the 737 follows. How long will they be the same distance away? That's what it's asking. At what point will the distances be the same? That's what it's asking. So the 737 has a cruising speed of 517 miles per hour. And the Saab 340 has 290 miles per hour. Much easier to keep things organized, what we have. Here we have the plane. And our formula we're using is distance equals rate times time. So distance equals rate times time. Let's plug in what we know. We have the 737 here and the 340 here. So it gives us 517. Is that the distance, rate, or time? It's the rate. It's the speed in which it travels. And the Saab is 290. The time. If they took off at the same time, the times would be equal. But the Saab took off an hour before it. 1 hour, so we add 1 hour to its time. And we want to know when they overtake each other. So when the distances are equal. So we want to know the distance of the 737 when it equals the distance of the 340. So the formula for distance is rate of the 737 times its time and the equals the rate of the 340 times its time. If any of you ever interested in becoming pilots, we used to have a flight school here. Back in the old days, there used to be an airplane right out here where those benches are, where those tables are. We used to have a Beechcraft out there. And John Payne, if you're interested, talk to John Payne. He's in our math department. He used to be the chief instructor here. He's got 1,000,000 hours. That's what I learned from him. So if you're interested, I'm talking to some of the executives to try to get that program back here. Because think of how many pilots now are ex-military that are getting ready to retire. And they make sweet money. And think about it, if you think about it, what does it entail? Sit there, autopilot, and then and then turn it back on and we get ready to land. I mean, they even have planes now that they could taxi themselves, they could take off, they could land, and they could go back to the terminal by itself. Pilot's just there in case anything bad happens. But anyway, so what's the rate of the 737? 517 times its time is equal to 290 times its time, which is t plus 1. So we multiply, get rid of the parentheses, and then distribute that one. So it's 290t plus 290. We have t's on both sides. Move the smaller to the larger. So we subtract 290t from both sides. So we have 227t equals 290. Yes.
The 227 or the 290 on that side.
On this side, they're here. Because remember, the formula for the Saab was 290 times t. Their t was t plus 1. So when I multiplied 290 times t, then 290 times 1, that's where I got the 290. Now, when you deal with word problems, it's important to remember what units you're dealing with. What unit is the time in? Hours. So whatever this decimal becomes, that's how many hours you have. So if you had, let's say, 1.5, that would be 1 hour, 30 minutes. So whatever the decimal is, you have to correspond that to the 60 minutes of the hour. So that's motion problems. The hardest part about the motion problems is figuring out which one do you add the time, extra time to. It's whatever one left first. Then we have simple interest. Whenever you borrow money from anybody or anything, you'll always have to pay it back with some sort of interest. That's just the cost of borrowing money. And unfortunately, now it's been deregulated. So your credit cards could be up to 19%, 25%, which means what? Which means for every $1 that you borrow from that bank for the credit card, you're paying 25 cents back in interest. So when you pay them, only 75 cents gets paid off every dollar going to what you owe them, which is criminal. Unless you have very high credit rating, then you could get better cards with 8-9% interest. Very important. Buying cars, same thing there. I mean, that's one of the first big expenses you ever have in your life. So shop around, try to make a bigger down payment as you can, save up money, and don't let your eyes take hold of your checkbook, because you might want a fast car. It's cost $50,000, $60,000. All that's going to do is make you go broke faster and get you in, probably, if not killed, then get you lots of tickets. Go broke much faster. So start off small. Start off with something that you can take care of yourself. Oil changes, minor tune-ups, and stuff like that. By the way, that's simple interest. The interest formula is dependent on three things. It depends on the principal, the rate, and the time. Principal. One of those spellings, because one's a person at your school, the other one's how much money you got. So one of those, I always get those mixed up. So what's that? Principal? Principal, okay. PLE. The principal is the amount borrowed. That's how much you borrowed initially. Rate is a percent of that amount you borrowed that you will be penalized for, depending on the number of time periods. This is where you have to be very careful, because time can be annually, once a year, biannually, which is twice a year, monthly, weekly, daily. So depending on who, like those quick check cashing ones that will borrow money from your future credit, your future payment, don't ever trust those, because they'll rob you. If you ever need money, go start off with your family, friends, church. Use them as last amount possible. But anyway, putting these all together will tell you how much money you owe above what you borrowed. So this is just the interest. What you pay back is the principal plus interest. We call this the annuity. The annuity is what that note is worth. The reason they call it a note, because back in the old days, you used to sign IOUs on a piece of paper, a note. It said, I owe you this much money for borrowing this much money. And then it was notes that banks made more formal. And this is simple interest. It's a one-time interest. That's all. Then you have more complicated ones called compound interest, that it's either done by day, week, month, year, or it could be multiple years. It all depends what they want. So let's look at this example. Where is that? There it is. Student loans. The Marion's two student loans total 28,000. One loan at 5% simple interest and the other at 3% simple interest. After 1 year, he owes 1,040 in interest. What's the amount of the loan, of each loan? Okay, I think they use 1040 because that's the same name of your tax form that you fill out, the 1040. But, so let's see how we do this. This is example 8. Remember, we have the interest, which is principal rate times time. So our table, this is the note. The principal. The rate. The time. And this is, since we have multiples, amount owed. The interest. Because this is principal times rate times time equals interest. So we have two notes. We have the 5% note and the 3% note. We'll call this one A and this one B. Do we know how much we borrowed from there? We know we borrowed 28,000. But how much did we borrow from each one separately? So, well, since we don't know anything about that, we know that we borrowed X amount of dollars on this first interest. So that amount is gone from the 28,000. So the other one is 28,000 minus X. That's the amount of money we borrowed for the second one. The rate, 5% equals 0.05. 3% equals 0.03. Because remember, 5% is 5 over 100. So move decimal 2 to the left. So you have 0.05. How long do we keep them? 1 year. So the interests, we have the PRT. So we have the X times 0.05 times 1. 28,000.03 times 1. And together, both of these interests have to equal 1040. So now we have our equations. We have the amount of interest for A, which is 0.05x, which is this right here. And for B, we have 0.03, 28,000. Oops. There's minus X in this one. Minus X. Because it's this formula here that goes there. 28,000 minus X. So what do we do with these equations? A plus B has to equal 1040. That's the interest. So it's 0.05 X plus, we could distribute those. So 0.03 times 28,000 minus 0.03 X. Since we have two decimal places, we can get rid of two zeros. So that's 3 times 280. That's 3 times 0, 0. 7, 8. So that's what B is. B is 840 minus 0.03 X is equal to 1040. Well, combine like terms. 0.05 minus 0.3 is 0.02. Subtract 840 from both sides. Point 0.02 X equals 0.002. We multiply both sides by 100 to get rid of the decimal. So it's 2X and just put two more zeros behind there. So X is equal to 10,000. $10,000 is X. What does X represent? The amount that 5% borrowed. So the amount that B borrowed is 28,000 minus 10, which is 18,000. So those are the amounts. 5% borrowed 10,000. 3% borrowed 18,000. And together they 28,000. Yeah, and that's the last thing. Zeros, when we talk about zeros, those are the x-intercepts. So if I said, if I give you a function f(x) equals 3x plus 2, what's the zero there? Set it equal to 0 and solve for x. Remember, zeros are the x-intercepts. Set y equal to 0 and solve for x. All right. So that's the last word I forgot. We have zeros, solutions, intercepts. Those are all the same thing. Okay, everybody, have a great, safe weekend.